Welcome to our video lecture on basic laws of circuit theory. Myself, Kumar Banerjee, Assistant of Electrical Engineering Department, Dr. Sudhir Chandra, Degree Engineering College. In this lecture, we will discuss about the basic law of circuit theory, that is based upon Kirchhoff's law. Basically, there are two types of Kirchhoff's law. One is Kirchhoff's voltage law and another one is Kirchhoff's current law. And the most basic law of electrical engineering, that is Ohm's law. Based upon the Ohm's law, all the other laws has been implemented, and Kirchhoff's law is also the part of that. So, in this lecture, we will discuss about how the different kinds of electrical circuit analysis can be done by using Kirchhoff's law. And before understanding the Kirchhoff's law, we have to understand several things of circuits, and that we will also discuss in this lecture. So first we will start with the Kirchhoff's law's basic needs. Kirchhoff's laws are basic analytical tool in order to obtain the solution of currents and voltage for any circuit. That means if we want to calculate the current and voltage of a circuit by using Kirchhoff's voltage law and current law, we can easily do that. Whether it is supplied from direct current system or alternating current system. That means Kirchhoff's law is applicable for both DC current as well as AC current, alternating as well as direct. But with complex circuit, the equation connecting currents and voltage may become so numerous that much tedious algebraic work is involved in their solution. The factor is that when the network is much more larger, it contains different types of loops and meshes are there, or different branches are implementing there, then by using Kirchhoff's laws, the algebraic equations becomes very much larger and it is difficult to solve. For that case, several different laws are also, several theorems are also there to solve those kind of larger problems. But here we will discuss only about the simplest form of electrical circuit law, that is called Kirchhoff's theorem. Kirchhoff's law. But here we will see that the elements are generally encountered in an electric circuit can be interconnected in various possible ways. Before discussing the basic analytical tools and that will determine the current and voltage at different parts of the circuit, some basic definition we will discuss now. So this is a simple network. Here some resistances are present and there are some voltage sources. All the voltage sources are here present, that is DC voltage sources, and this is the ground. Now in this simple circuit there are few things. One, this is a closed loop. This thing is called loop. That means here we have three loops are there. 1, 2 and 3. Second one, there are nodes. Nodes means where two branches are meeting together. Here, this is the node. And this is also another node where several branches are meeting. Here, this is the ground node or data node. So this thing we will discuss now. The basic definitions of a given network or some network. So first thing is node. A node is an electric circuit, is a point where two or more components are connected together. Previously I have already highlighted that part. What is node? Where several components or branches are connected together. This is called node. Second one is branch. Branch means a branch is conducting path between two nodes in a circuit containing the electrical elements. That means these nodes are definitely connected with some electrical components like resistor, some voltage, and between these nodes where the electrical components are present, that is called the branch. These elements could be sources, resistance, or other elements. That means all the elements are present in that path that will be included in the branch. Third one is loop. A loop is basically a closed path in an electric circuit. That is, a closed path or loop in a circuit is contiguous sequence of branch with starting and end points for tracing the path are in effect the same node and touches a node more than once. So there are three loops in this circuit. I have already shown you previously. This is loop 1, this one loop 2, and this is loop 3. That means where no other branches are inserting and this is forms a closed path. So this is called a loop. Next is mesh. A mesh is a special case of loop that does not have any other loops within it or in its interior. Figure 3.4 indicates there are first 3 loops. Here, these 3 loops are basically 3 meshes. And why it is called mesh? Because no other loop is included in it. So if we are considering this loop, that suppose A, B, C, G, A, this loop is combination of 2 separate loops, 1 and 2. That means this is not a mesh. This is a loop. But this loop includes 2 another loops. So that means this is not a mesh. But if we consider about A, B, G, A, this is a individual loop where no other loops are present. That means this is a mesh. So, for Kirchhoff's law of understanding, this loop concept and node concept is very much required. And here 2 diagrams I have shown, that is based upon these 2 diagrams, 2 Kirchhoff's laws has been made. First diagram, it is based on Kirchhoff's current law, and second diagram, it is based on Kirchhoff's voltage law. So first I will describe about Kirchhoff's current law. In short, it is also known as KCL, Kirchhoff's current law. KCL says that at any node or junction in a circuit, the algebraic sum of currents entering and leaving a node at any instant of time must be equal to 0. That is, in short, suppose there are 2 currents, like this is I1, this is I2, this is I3, this is I4, and combination of all these currents will be equals to 0. That means I1 plus I2 plus I3 plus I4 equals to 0. But here we have to see one thing, the directions. When the direction are entering, that means the current direction towards entering the node, then the currents will be taken as positive. And when the currents are leaving from the node, then we will take it as negative. That means here 2 currents are entering, I1 and I3. These 2 are entering, that means these 2 will be positive sign. And I4 and I2 are leaving, these 2 will be negative. That means summation of I1 plus I3 minus I2 minus I4 equals to 0. So here it will be I1 plus I3 minus I2 minus I4 equals to 0. Or in other words, you can write the same thing in form I1 plus I3 equals to I2 plus I4. That means the summation of currents entering in a node equals to summation of currents leaving from nodes. Summation of currents entering in a node is equals to summation of currents leaving from the node. That is also Kirchhoff's current law. Next, Kirchhoff's voltage law. It states that in a closed circuit, the algebraic sum of all sources voltages must be equals to the algebraic sum of all voltage drop. That is, in short, summation of voltage drop in a closed loop equals to 0. That is basically Kirchhoff's voltage law, in short KVL. So, voltage drop is encountered when current flows in an element, resistance or node, from the higher potential terminal toward the lower potential terminal. That means current going from positive to negative. That is the basic part. Voltage rise is encountered when the current flows in an element from lower potential terminal towards the higher potential terminal. The Kirchhoff's voltage law is explained with help of the given figure. So here we can see that the Kirchhoff's voltage law can be applicable here because this is a closed loop, and in this closed loop there are few resistances are present, R2, R1, R5, R4, R3, and there are few voltage sources are also present, that is V1, V2, V3 and this one V4. 4 voltage sources are also present. That means in this closed loop, summation of all voltage sources and voltage drops all equals to 0. Again the same thing we have to consider the direction of flowing of current. The current is flowing from positive to negative and the voltage sources are present. As per the diagram, the currents will be flowing whatever direction according to that positive or negative sign will be placed. So here definitely this is flowing to negative to positive, so V1 is positive. Then I1 R1 drop, definitely here inside it is I1 R1 negative. Then R2 minus IR2, negative resistance drop. Then the direction of current it is opposite, so it is minus V2, then minus IR3, then minus IR4. Again the direction of V3 is same with V1, so it is positive V3 plus minus IR5 minus V4. All the directions are negative apart from V3, so all the values are taken negative, and according to that the voltage drop you can calculate, and all the summation of voltage drop plus sources equals to 0. That indicates our Kirchhoff's voltage law KVL. So let us, we are taking a small example. For the given circuit shown here, calculate the potential of points A, B, C and E with respect to the point D. Find also the value of voltage source V1. So, we are assuming that the direction of closed path is D, E, A, B, C, D. That means the current is flowing through D, E, A, B, C, D in this direction. So 50 volt source is connected between terminal D and E, and this indicates that the point E is lower potential than D. So VED is equals to minus 50 volt. Similarly, VCD is also opposed in positive direction, so it will be positive 50 volt. Or if we consider VDC, then it is minus 50 volt. Similar, 500 milliampere current is flowing through 200 ohm resistor, and from A to E, the direction is here, opposite direction. And if it moves from lower potential E similar higher potential A, this shows that a rise in potential, that means VAE equals to positive 100 volt and VAD equals to minus 50 plus 100 equals to 50 volt. Similarly, VCB equals to 35 volt. Now, putting all these values using KVL in the closed loop, we will get that the value of V1 is 35 volt and VED is 50 volt, VAD is 50 volt, VBD is 15 volt and VCD is 50 volt. In this way, we can calculate the problem of the simplest one using Kirchhoff's voltage law. So this much up to today. In my next class, we will again discuss about Kirchhoff's current law and voltage law and some numericals we will solve to understand the problem. And you must go through different books of circuit theory like H. Chakraborty. You can go to Dr. Rajoguri book also. That is also a very good book. And PC Roxy book you can also follow. KCL KVL part numerical problems you must solve to understand the basic needs for circuit theory or any circuit calculation. So thank you for listening my lecture.